You're listening to the Future Tech Health Podcast with Richard Jacobs. Until I reached age 40, I never realized the obvious, that we all have medical issues, or we at least have a family member or close relation that had, has, or will have them in the future. Medicine and biological systems are the final frontier. Until we've conquered death, figured out how life began, cured cancer, and understood our purpose in the universe, there's a heck of a lot to talk about when it comes to our health. Future Tech Health means I'll be covering futuristic topics that are actually already in clinical trials, or even starting to appear on shelves or by prescription, or available for your own use. We dive deep into stem cells, CRISPR-Cas9, the science of sleep, epigenetics, medical testing, cancer, ketogenic diets, stem cells, aging, regenerative medicine, and more. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a serious medical problem. Remember, however, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and share it with friends. Thank you. Hello, this is Richard Jacobs with the Future Tech and Future Tech Health Podcast. I have Martin Pall. He's a professor at Washington State University, and we're going to be talking about the effects of microwave radiation, EMF, the activation of highly sensitive voltage-gated calcium channels in cell membranes, and also other effects of microwave radiation on the body. So, Martin, thanks for coming. How are you doing?
I'm doing fine, thanks. Good to be with you.
Yeah. So, for people that, let's lay out the basics. What are these sources in the everyday lives of people where they're getting, EMF, it's electromagnetic frequency radiation?
Let me just say, I've mostly focused on microwave frequency EMFs, which include all the wireless communication devices. And so there we're talking about cell phones, cordless phones, cell phone towers, Wi-Fi, smart meters, and but also radar, which broadcasts in the same region. But there's similar effects that also come from broadcast radiation and also from extremely low frequency exposures from our power wiring. And in fact, what I've shown is that all the frequencies, all the way from millimeter waves down through microwaves, radio frequencies, intermediate frequencies, extremely low frequencies down to static electrical fields and static magnetic fields, they all work on the same target. They all work by activating voltage-gated calcium channels, which is a really, truly stunning finding and a very important one.
All right, so what does that mean they work on these channels? What function do these channels serve in the body? And what does the EMF do?
Yeah, so let me just say, first of all, the voltage-gated calcium channels, as far as I can determine, occur in every single cell in the body. They're most important in the electrically active tissues, which include the nervous system, the heart, and other kinds of muscle. And they're also involved very intimately in the release of hormones and the release of neurotransmitters. So those are some of the more important things, but they do many, many other things. And, so basically what's true is that normally calcium levels in the cells are maintained at a very low level. So usually calcium in the cell, intracellular calcium, is about 1/10,000th the concentration outside the cell. So these channels are only used to very briefly increase intracellular calcium to produce regulatory responses. What happens when you have the EMF exposures is that you get much higher activation of these channels than is normal, and so you get much higher amounts of intracellular calcium, and it's that intracellular calcium is very important, and it causes all kinds of havoc. And so that's basically the main biological mechanism of action of all the EMFs goes through that mechanism.
So how do they affect the calcium channel? Do they halt it? Do they accelerate it? Do they change it in some way? I mean, what appears to be the effect?
Okay, they activate the channel, they open the channel. Okay, so the channel most of the time is kept closed. And so what the EMFs do is they open the channel. And the way this works is that these channels have a structure called the voltage sensor, which has the function of detecting electrical changes across the plasma membrane and opening the channel in response to those. What I've shown is that when you look at the structure of the voltage sensor, which is known, and the location in the plasma membrane, which is also known, the physics of it predicts that the voltage sensor is extraordinarily sensitive to the electrical forces produced by these EMFs, and that the force on the voltage sensor is approximately 7.2 million times stronger than the forces on singly electrically charged groups that are in the aqueous parts, in the watery parts of our cells and bodies. And so that's a huge effect. And
one way to restate that, if we were to restate that, there's a tremendous voltage or electrical potential across our cell membranes, inside and outside. Is that what you're saying?
Well, not exactly. So
so I wanted to clarify.
Yeah, I mean there are electrical charges across the membrane, and they are changed by the EMFs, but that's not the only reason why the voltage sensor is so sensitive. Part of the reason is that there are 20 charges in the voltage sensor, and so when you're comparing it with a single charge, that gives you 20 times higher forces. Another thing, and this comes out of a law of physics called Coulomb's law, is the forces on those charges are about 120 times higher because of the dielectric constant of the region that they're in. And so the forces are much higher because of that. But then there's also a high-level amplification of the charge across the plasma membrane, and so this relates to your question, and that gives you about a 3,000-fold amplification right across the plasma membrane. So that's a big effect too. That's the biggest of them, and so you multiply these together and you come out with 7.2 million. So it's a huge effect, and so the voltage sensor is extraordinarily sensitive to these forces, these even quite weak electrical forces, and that's why these voltage-gated calcium channels are activated by these weak EMFs, and that's the kind of core of this thing. As I say, the industry has been claiming for years that these forces are too weak to do anything, and we now know exactly why they're wrong about this.
So what's the implication? What appears? Have we tested this in rats? Are we able to just look at people and see the effect of their constant exposure to EMFs? I mean, what is this doing?
What's it doing to us, and what's it doing to... Well, so there have been many studies that have been done on human cells, on animals and animal cells, and so we know a lot about these things. And there are 8 different very important effects, each of which have been demonstrated over and over and over again and have been reviewed in many different review articles, from 12 to 35 different review articles on each of them. And those include effects on our neurological and neuropsychiatric function. So there are heavy impacts on the brain. In fact, there are heavy impacts on the entire nervous system, but of course the brain is particularly important. And those impacts on the brain of the EMFs cause these neurological and neuropsychiatric effects. And those effects appear to be cumulative. That is, they get worse and worse as just with increasing times of exposure to the same kind of EMF. And as the effects become more severe, and they do become severe in animals and in humans, they become irreversible. The neuropsychiatric effects include essentially all the things that everybody complains about. I can't sleep, I'm tired all the time, I can't concentrate, I'm depressed, I'm anxious, my memory doesn't work. I've got headaches, I've got all these things that have become very, very common complaints of people in technologically advanced societies all around the world, we know are caused by EMFs, and we're ignoring all this stuff. And we know that, at least based on the best available evidence, that these effects are cumulative, and as they become more severe, they become irreversible. So this is an extraordinarily serious situation, which is just being ignored by the industry, by the regulatory agencies, and by governments around the world.
So if you were to make a Pareto of most highest exposure or most effect on the human body, the least, what are some of the top things that are affecting us the most, and in what context? Is it sleeping with your cell phone in the bedroom next to your bed, or in your bed, or is it other things that are affecting us more?
There are many exposures that are quite substantive, that create substantive effect, and the cell phone exposures are one of them. Cordless phones also produce effects. In fact, the cordless phone base stations also produce effects. So if you've got a cordless phone base near your bed at night, you're getting irradiated by that all night. It doesn't have to work that way, but that's the way they do work. So, we're
I mean, they're not shielded, although they could be and still function.
They don't really need to irradiate when you're not getting phone calls, but they do.
Okay.
They're stupidly designed. I mean, this is we have all kinds of things that are stunningly stupid. And let me just say again, I talked about the neurological neuropsychiatric effect. That's only one of many effects that occur. It's one of the two or three that I'm most concerned about, but it's not the only thing that's going on.
Yeah, before I do want to ask you more about the other effects, but again, just as an initial point, so people can immediately take some kind of action to mitigate the effect on them. Again, what are the things that the average person is exposed to in a day that they have any control over, that they can do to reduce their EMF load? I guess maybe you call it an EMF load for the day, 24-hour load.
Okay. Well, okay, so that's where I was going. Okay, so what else do we have? We have the radiation from the cell phone towers. People who live within 300 meters of a cell phone tower, which is about 1,000 feet, are impacted by that radiation. And that includes a very large fraction of our population. Now, you are saying, well, you can't control that. And it's difficult to control, but it's not impossible. I mean, you can put shielding up between, even if you're living near a cell phone tower, you can put shielding up to help protect yourself from the cell phone tower radiation. So we have probably half of the people in the U.S. who are substantially impacted because of the cell phone tower radiation, either because they live near it or because they work near cell phone tower or they go to school. And the idea of putting cell phone towers on schools is an abomination. It should be no such things, but we do have them, and so that's a huge issue. And so I think that. And they do produce the neurological and neuropsychiatric effects. They do produce also other effects, including cancer and including life-threatening cardiac effects. And so there's lots of things going on there and great concern. We live in a situation where it's just incredible what the situation is because, for instance, in the United States of America, this country that we pride in terms of our science, all the science funding, the government funding for science in this area was cut off between 1986 and 1999. And the consequence of that is that the U.S. government, through the FCC, has been pushing something like 350,000 cell phone towers to be put up all over the country, irradiating essentially everybody, but producing substantial irradiation for, at least half of the population that we have, and they have not funded one single study on health impacts of people living near cell phone towers. All of the studies that have been done on that have been done elsewhere. Nothing's done in the U.S.
Elsewhere meaning where? Elsewhere meaning overseas or elsewhere?
Other countries, yeah. Some of the European countries have done studies. Not all of them, but some of them have. There have been studies done, and there was one study done in Brazil. There was one study done in Israel. There was one study done in Egypt. There was one study done in Saudi Arabia. There's one study that was done in Japan. I mean, they're scattered around, but but what's striking is that we take great pride in our science, and in this area, we're doing nothing. What's happening is that the government is pushing this technology on us and is doing absolutely nothing to protect us.
Well, what about with the coming 5G networks? Have you or anyone studied the implications of those? Because from my understanding, part of the 5G network at least will require many more small transmitters in a much more densely packed arrangement in order to move data.
Yeah.
More than the existing, cell network.
There have been many people who've been very concerned about 5G, and I'm certainly one of them. I have profound concerns about 5G. I think in order to understand 5G, you really have to understand a bit more about microwave frequency things. You have to understand some things that we haven't talked about yet. So let me talk about some of those because I think they're very important. One is that it's been known, actually going back over half a century, that pulse EMFs that pulse up and down, are much more biologically active in most cases than our non-pulse EMFs, or what are called continuous wave EMFs. The reason that this is important is because every single wireless communication device communicates via pulsation. And the smarter they are, the more they pulse. And therefore, potentially, and I believe actually, they are much more dangerous as a consequence of that. So this is a very important factor that is completely ignored by the industry. It's completely ignored by the FCC and the other regulatory agencies around the world. And yet this has been known for a long time. The first review that was published on this was published back in 1965. So we know that this is a very important factor. Now, why is it important with 5G? 5G is designed to be especially highly pulsed. That's the whole idea. The whole idea behind 5G is to use millimeter wave frequencies, which, because of their frequencies, they can pulse a lot more than the microwaves can, and therefore carry a lot more information per unit time. That's the basic idea behind 5G. And so 5G will be extraordinarily highly pulsed, and yet we have no biological safety testing of anything even vaguely resembling genuine 5G radiation with the high level of pulsation that it will entail. So what has been already approved by the Congress, by the FCC, is to put out, as you stated, huge numbers, something like tens of millions of these antennae out all over the place. They are designed to communicate with what they call the Internet of Things, with billions and billions and billions of other devices. Now, the more devices they're communicating with, the more the pulsation's going to be. So even if you put out 5G, which is being done now, the effects that you see immediately, and there are reports of serious effects, which of course are denied by the industry, and basically what we have is a situation where whatever the pulsations are, at this point when you're putting these things out, is going to be a tiny, tiny fraction of the total pulsation level that, is planned for the whole 5G system. So let me just say, I think it's absolutely insane to put out tens of millions of these antennae in close proximity to essentially every building in the country. So such that it's almost impossible for people to avoid exposures, particularly when they're outdoors. And put these out without doing any biological safety testing whatsoever. But that's what's happening.
All right. So I'm getting a picture here. One way that people could possibly intervene is, at least, for the 8 hours, hopefully they're sleeping. Maybe the 10 hours they're in their home with, rummaging around, waking up, showering, and then sleeping. They at least can reduce their EMF exposure for, not half the day, but close to half the day, at least a third.
Yeah.
So, are you more interested in the science of this, or do you want to translate this into like actionable recommendations for people? Do you have friends, family, etc., that come to you and say, Martin, I believe you. I can see this is serious. I'm even having the effects. What do I do to mitigate these effects on myself?
Okay, so there are two levels at which we need to act. One is at the individual and family level, and that's the one you're raising here. And the other is at the political level. If this goes through, it's my opinion that no matter what we do, we're going to be destroyed quickly. We can slow it down a little bit, but we're in an absolutely horrendous situation. That's my opinion, and I think that. And as I say, we've only talked about one kind of effect, the neurological neuropsychiatric effects. There are undoubtedly many others which are of high level concern. But you can shield yourself to some extent from 5G radiation in your home. It's not always easy, but you can do it. You can use things like graphite paint, which absorb EMFs quite well. Graphite paint is black, but you can paint over with some other color, so you're not looking at black walls. And people who are in apartments, can protect themselves from not only from 5G but also from Wi-Fi radiation from their neighbors by using shielding. But there you have to worry about not only the walls, you need to also, of course, you need to worry about the windows, and you need to worry about your ceilings and floors too. So there are multiple problems. You can do things to to improve the situation, but it's challenging. And similarly, when you're driving around, you can, to some extent, although we're not really set up to do this well, I think at this point, you can put shielding in your vehicles, on the windows and on the doors and so forth, to help shield yourself from the EMF. So there are things that can be done. But think about what kind of horrendous situation we are in when we can't walk around outside. Where we have to put, we have to wear shielding over our heads and on our bodies and stuff. Now,
well, again,
yeah,
I would bet that the effect from a given EMF source falls off, I don't know, with the square of the distance, or is that not accurate at all? Meaning if I'm 5 feet from a cell tower emanation source versus 20 feet, or 5 versus 10, what's the
okay? So let's talk about another thing here. Okay, so the intensity of the radiation drops off with the square of the distance, as you said. But that doesn't really tell you as much as you'd like about the intensity of the effect. And the reason that this is a major issue here is that there is another large literature which shows that there are what have been called exposure windows. So specific exposure ranges, sort of small ranges of exposure where you get maximum effect. And when the intensity goes lower or higher, they drop way down. So they drop way down, they go down. So when you get an increase in exposure, and there was one study done, for instance, where there was a particular exposure window, and they went up to higher and higher exposures, and they went up to 150 times higher exposures, and it was still lower than it was before. The effects were lower.
The frequency of the pulse, or what modulated it? What modulated the effect?
No, this is the same kind of pulse. It's just simply you're varying the intensity. That's all. You're just varying the intensity. So you have very complex dose response curves, which means that you cannot really predict these things very well. Now, it's still the case that on average, based on the available data, that in most situations, an average higher level exposure produces, in most cases, bigger effects than an average lower level exposure. But there are lots and lots of exceptions to that. And so basically what that means is that all the predictions that the industry makes based on their models of what's going on are wrong. We know they're wrong. And the consequence of that is that the safety guidelines that are supposed to protect us are completely bogus. They simply don't tell us anything useful about safety. And so to call these safety guidelines is simply fraudulent. And again, there are multiple findings that have been repeatedly found over and over and over again that tell us that. Okay, so this is not speculation. This is not. These are highly repeated findings. Which
so what's your goal here? Is it just document the effects?
My goal is to save one country in the world from this. That's my goal. Because if we don't do that, we're just all going down. And we've only just talked about one effect, right?
Well, let's go on to the other effects. Yeah.
Okay, so another effect that occurs is a reproductive effect. There are reproductive effects that have been found, that have been reviewed, I forget, 20-some times, in animals and in humans. And what you get changes in the structure of the testis and of the ovaries. You get lowered sperm count, lowered sperm motility, other measures of lowered sperm quality. So all those inevitably affect reproduction. You also get fewer eggs produced, and this has only been studied in animals, to my knowledge. You get increased spontaneous abortion. That's been studied both in humans and in animals. You get lowered levels of each of the 3 types of sex hormones. Estrogen, progesterone, and testosterone all go down. And you get lowered libido. That's not surprising given the fact that the sex hormones are down. So there's all kinds of things going on here.
What's the order of magnitude of the lowering in all of these things? Any ballpark range?
Well, it depends on the condition. So let me tell you about a very interesting study that was done in mice that was published 21 years ago. And what they did was to take This was published by Magros and Xenos, and what they did was they took young pairs of mice, one male, one female, stick them in a little cage on the ground outside in an antenna park. So these were a series of broadcasting antennas where the EMF levels at ground level were well within our safety guidelines. And they did this in two locations, one with a somewhat higher level exposure, one with a somewhat lower level exposure. Now, mice have a gestation period of 30 days. So they could produce a litter in 30 days, another litter 30 days later, and so forth. And what they found was that the higher level exposure, again, all within our safety guidelines, there was an immediate drop in reproduction in the first litter, and there was a drop in reproduction in the second litter, and there was no third litter. Reproduction crashed to zero. And when they took these mice out of the EMFs to see if the reproduction would recover, they found essentially no recovery. So the effects were cumulative, right? They didn't all work on the first litter. You got cumulative effects over time. And basically the same pattern, by the way, occurred at the lower level exposure. The only difference was it was the fifth litter that crashed to zero, not the third. So
might be interesting. What about the offspring of the first and the second litters? Were they affected?
I don't know that they didn't look at that. That's actually a very good question I think you're raising. And the reason is that it's a good question, or one of the reasons anyway, is that there are DNA effects which occur in the germline cells. And so, for instance,
you're saying epigenetic effects, or are they genetic?
No, these are DNA. These are effects on the structure of the DNA that produce mutation. So you get both single strand and double strand breaks in the cellular DNA. You also get oxidized bases in the cellular DNA, and those occur in human sperm from exposures that we're commonly exposed to. So this is now the reason that I think your question is an important one is particularly because when you get the double strand breaks, they produce chromosomal rearrangements. And by the way, the first studies of chromosomal rearrangements that were found from microwave frequency exposures were found back in the late 1950s. So this has been known to occur. This was done in animals. This has been known to occur, over half a century ago. We're ignoring all this stuff. I mean, it's just amazing what we're, I mean, it's just incredible that we would be ignoring all this stuff. And so what the reason that's relevant to this issue of reproduction is that when you get these chromosomal rearrangements, the individuals that receive these rearranged chromosomes sort of act reproductively as if they were a different species. So that when you get people mating that have different chromosomal combinations and they try to reproduce, you can get these delayed effects produced as a consequence of these chromosomal rearrangements. And it's just sort of like you cross a horse and a donkey and you get a mule which is sterile. It's the same sort of thing. Now, how severe it's going to be will vary depending on the individual case. But the point is that there are almost undoubtedly delayed effects, things that you don't see immediately in terms of reproduction.
Yeah, how long, if you made a chart or a graph of the average EMF load on a person in a 24-hour period over the past 5, 10, 15, 20 years, have you done such a thing? Do you know what that would look like? And if it's been long enough, we would probably see changes in the next generation. Let's say it's been 15 years where it's significant.
Mm-hmm.
I mean, that's plenty of time for people to be born and grow up to an age where they're, they would be changed. There'll be widespread evidence of that, I would think.
Well, we are seeing problems with reproduction around the world. The problem is that you can't really say whether those are immediate effects or whether those are delayed effects. So, that's not the issue. So let me tell you what the situation is with regard to reproduction in human populations, okay? Let me talk about that. Sperm counts have dropped to below 50% of normal in every single technologically advanced country on Earth. Reproductive rates have dropped to well below replacement levels in every single one of those countries with one single exception. And the lowest reproductive rates have dropped down below 60% of replacement. Now, I've been predicting for a while that we'll see crashes in reproduction somewhat similar to what was found in the mouse studies that we talked about. And up until recently, I haven't seen any evidence that that was really true. We've certainly seen drops in reproduction, but we haven't seen crashes in reproduction. Now I think we're starting to see crashes in reproduction, and these have occurred in three small, densely populated, high technology East Asian countries, and they've occurred between 2016 and 2017. And those countries are Singapore, which had a 31% drop in reproduction between 2016 and 2017.
In 1 year?
In 1 year, yeah, 31% drop.
When you say reproduction, do you mean like successful births, or what's the metric there?
This is in terms of birth. The figures are in terms of birth rate per woman. Okay, so this is a standard way of measuring, whether reproduction is. So you need to have something like 2.1 or to 2.2 births per woman in order to maintain a stable population. Okay, so if it drops below that, you're below replacement levels. And so these countries, so those two have dropped dramatically. The third country that's been impacted is South Korea, where there was an 11% drop in reproduction between 2016 and 2017. The South Korean figures are now available for the first 6 months of 2018, and there was another approximate 9% drop during that time period. So all three of these countries are down, down in the 40s in terms of they're down in the 40%, between 40 and 50% of replacement levels. So that means within one generation, and this doesn't, of course, happen immediately, and it depends on birth rates and death rates and what the ratio is between them. But
what about the ratio between pregnancy versus birth rates? You said the reproduction crashed 30 some odd percent.
Yeah.
So that's actual live birth.
So you're asking about well, I mean, there is an increase in spontaneous abortion, so that will be affected. But I don't have any figures for those specific countries.
Okay.
So there will be effects. My prediction is that based on the statistics that we have these three countries that are falling over a reproductive cliff. I think that the rest of us will follow along very shortly, and it may be that some of us already are. We just don't have the statistics yet. So we do not have statistics on babies per woman for 2018 yet. So we don't know what the figures were there. And so
but again, what if you saw not only a reduction in live births per person, but a reduction in pregnancy to successful consummation of it?
I think we know the EMFs do cause that, but as I say, I don't know. I really haven't tried to look up the figures for spontaneous abortion and whether they are increasing rapidly. I would expect they would be, but I haven't tried to research that. So there's only so much time in every day to do these things. Now,
that's what I'm saying. This is not a one-person research effort. It's going to take hundreds and hundreds of people. What's the state of funding for these kind of things? Is it just being ignored, or are people putting in requests for funding for grants?
Well, when you're a scientist and you're looking for grants, you find out very quickly what kind of grants get funded and what things don't get funded. And you put in proposals for areas that do get funded, because otherwise you're wasting your time. And that's, of course, the situation here in the U.S. So the U.S. and the U.K., which are usually considered the number one and number two science countries in the world, are doing nothing in this area and haven't done anything basically since around the year 2000. That's a very, very slight exaggeration, but only very slight. So we are, so the only funding you can get in the U.S. that is from industry, and they obviously have a huge vested interest. And it is possible to get funding in other countries, but it's not easy anywhere, I don't think. And so there are many things there where we need to do studies which are not being done. That doesn't mean that we don't have a lot of very important information. The problem is that that very important information is being ignored. It's being ignored by the regulatory agencies, and it's being ignored by the industry, and it's being ignored by governments, and that is a gigantic problem. It's also being ignored by the vast majority of the news media. So
Well, why not approach a country that's having a huge fall off of population with no end in sight, such as Japan, and the government does appear to be interested in ways to stimulate population growth so it's sustainable. Maybe they'd be more amenable to listening.
maybe, I don't know. I don't have any contacts in Japan. I mean, Japan and Korea are the two obvious places, and they both need high level concern about this thing. I mean, the there are many kinds of factors that can influence reproduction. The reason that I'm so concerned about this is that the effects on human sperm count and these three examples where we seem to be seeing a crash in reproduction. Here we're talking about things where we really don't have any other reasonable hypothesis that explains them, other than the fact that these are all high technology countries, densely populated, and they have high level EMF exposures, and we keep bringing out, as I mentioned before, smarter and smarter devices that pulse much more and are therefore potentially, and I believe actually, vastly more dangerous, and we keep ignoring that as well. So anyway, if you've got contacts in Korea or in Japan, and you can suggest somebody to contact, I'd be happy to do that.
Yeah,
So
I don't, but just a suggestion.
yeah.
Any other major effects that you haven't discussed?
Oh yeah, many of them. So there are hormonal effects. Essentially, all the hormone systems in the body are impacted by EMFs. There are cardiac effects, which are life-threatening, and they are involve the electrical control of the heart. Okay, so the heartbeat is controlled by what are called pacemaker cells in part of the heart called the sinoatrial node of the heart. And so those pacemaker cells have very high concentrations of these voltage-gated calcium channels because those channels are very important for controlling the heartbeat. And so what you find is that you get exposures. You can have exposures where you get essentially instantaneous increase in heartbeat. So you go from, you get about a doubling in the heartbeat just by turning on, for instance, a cordless phone, where the person doesn't know whether it's turned on or off, and the heartbeat goes way, 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 way up. And you turn it off, and it goes off. The increase goes off. So there are immediate effects that you see, where you get what's called tachycardia, rapid heartbeat. But over longer time periods of exposure, you get cumulative damage, which causes both bradycardia, slow heartbeat, and also arrhythmias. And the combination of those two are extremely dangerous. They're associated with sudden cardiac death. We have a large epidemic of sudden cardiac death in young, apparently healthy athletes dying in the middle of an athletic competition. And so this may not be the only explanation, but it's certainly an obvious explanation. And we have, so I think this is a big issue, and I have reason to think that these effects are also cumulative, and as they become more severe, probably irreversible as well. Okay, so there are those effects. Now, you also get oxidative stress, which is involved in essentially every chronic disease that we have. And so you get a big increases in oxidative stress in the body. You get big increases in inflammation. Those are also involved in many, many chronic diseases. And the underlying cause of all this is the increased intracellular calcium levels, which are produced by the voltage-gated calcium channel activation. They produce all of these things via known pathways of action. So we know a lot about what happens when you've got excess calcium in the cells and how you can get all these things. There are a number of other things which I think are quite likely and are also major concerns. But they're, I think, probably reasonable people can differ on how important the EMFs are. One of them has to do with very early onset Alzheimer's and other dementias. And we know that Alzheimer's and, in fact, other neurodegenerative diseases have that increases in intracellular calcium have major causal roles in all of them. So it's perfectly feasible for this voltage-gated calcium channel activation to produce early onset Alzheimer's and other dementias. There is some animal study that have been done that are really quite compelling, that have argued that these EMFs can cause Alzheimer's-like dementias in animals. And the other thing, which I think is very clearly documented, is that when your tissues, particularly the neural tissues, are exposed to the EMFs, you get large increases in the amyloid beta protein, which has a major causal role in causing Alzheimer's disease. So there are a number of different kinds of observations that argue that this is quite likely to be true, but as I say, this is something that where reasonable people may differ from one another. The other things, by the way, I don't think reasonable people can differ. I think that the only people who can differ are people who are following the industry propaganda claims. And but here people can differ. Another area where I think reasonable people can differ has to do with the role in causing the autism epidemic. In autism, we know that from genetic studies that increases in these voltage-gated calcium channel in the activity of those channels that's produced genetically can cause autism. And we know that that's important in causing autism in the broader autism population from genetic polymorphism studies. And I think we also know that autism involves a disruption in the formation of the synapses in the developing brain.
I don't mean to. We're running out of time, but what I'm sensing is that this, again, like I said, this is going to take hundreds of researchers and many, many well-funded studies in order for it to really make the impact it needs to make, which is a big problem, according to
Look, the problem is not that we don't have any research. We've got huge amounts of research that is very, very concerning. We don't need hundreds of researchers to do this stuff in order to be profoundly concerned about this. The evidence is already out there. What we're doing is we're ignoring it. Now, it doesn't mean there isn't a lot of research that should be done, but we do not need to wait until other research is done to have a vast amount of evidence that we are in extraordinarily deep trouble. Okay? I want to make that absolutely clear. There is vast amounts of evidence on the neurological, neuropsychiatric effects, on the reproductive effects, on oxidative stress, on the DNA damage, on the hormone changes. Another one that I haven't mentioned is you get increases in apoptosis, and that's important both in the producing the reproductive effects and producing Alzheimer's and other neurodegenerative diseases. That's going on as well. So, there's lots and lots and lots of evidence.
This is gonna make people curious and wanting to know more. So where should they start to learn more about the effects of EMF? And we'll close with that. So where should they go to either contact you or to learn more?
Okay. I have a 90-page document which is available on the internet that discusses all these different things, or almost all these different things. And you can search for it under my name, Martin Pall. It's Pall. Electromagnetic, 5G, and the date. And the date is very important. The date is May 17th, 2018. If you search under those things, you will find copies. You can download it, and you get all kinds of information, maybe more than you can chew on.
Okay.
But anyway, so, there's, and there are also, there are a lot of good YouTube videos on this stuff. Some of them I've given, some of them other people have given. There's a lot of information that can be accessed. So,
well, very good. Yeah. Well, Martin, I really appreciate you coming on, and thanks for doing this.
Okay, thank you.
You're listening to the Future Tech Health Podcast with Richard Jacobs. Until I reached age 40, I never realized the obvious, that we all have medical issues, or we at least have a family member or close relation that has, or will have them in the future. Medicine and biological systems are the final frontier. Until we've conquered death, figured out how life began, cured cancer, and understood our purpose in the universe, there's a heck of a lot to talk about when it comes to our health. Future Tech Health means I'll be covering futuristic topics that are actually already in clinical trials, or even starting to appear on shelves or by prescription, or available for your own use. We dive deep into stem cells, CRISPR-Cas9, the science of sleep, epigenetics, medical testing, cancer, ketogenic diets, stem cells, aging, regenerative medicine, and more. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a serious medical problem. Remember, however, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoy the podcast, please listen, subscribe, like, and share it with friends. Thank you.